Okay, today we are talking about roots of
That isn't sharp.
talking about the x-intercept. If you didn't know that, you might want to make yourself a note. Root just means the x-intercept. Okay, so for problems 1, 2, and 3, it says to find the zeros of the following functions. So problem number 1, we have y equals x. And here's another vocabulary term for us. What does the term zero mean? X-intercept. And we did that yesterday with the quadratic functions at the end of the notes and also at the end of the assignment. If you want the x-intercept, what do you put in for y? Zero. So let's do that for number 1. So if I put a 0 right here, well, what's the x-intercept? It's just 0. So x equals 0. Now, if I were to sketch a graph of that real quick, y equals x, what is that called? The parent function. And there it is. And where's it just the x-axis? At 0. So it works. Now, next one, number 2. Again, if I want the x-intercept, what do I put in for y? Put in a 0. So I'm going to just put this 0 right here. And solving for x, instead of add 4, we need to subtract 4 to both sides. And that gives us that the x-intercept is -4. Go ahead and see if you can do number 3. Okay, so how is number 3 different from problem 1 and 2? It's quadratic, but I'm still going to put the 0 in for y. And yesterday with our quadratics, we said there's several ways that you can solve a quadratic equation. You can solve by factoring, solve by completing the square, or quadratic formula works for every single quadratic equation. Now for this one, what would be the easiest and fastest method? Factoring. So what two numbers multiply to 1 and add to 2? 1. So we have x plus 1 and x plus 1. Then once we have these in factored form, what do we do next to solve it?
Take the square root of both sides. Each side is x plus 1 squared.
You set your factors equal to 0, or you could write it as x plus 1 squared and then square root it. But oftentimes when students take the square root, they forget the plus or minus. So here, let's just set the factors equal to 0. So x plus 1, set it equal to 0. X plus 1, set it equal to 0. So what's the x-intercept? -1. Now, do I have to resolve it over here? No, but this is called a double root, and it's called a double root because it actually has 2 factors with that x-intercept. And we'll see what a double root looks like graphically here in just a few minutes. Now, what we do need to notice, what happens if you go from factor form down to your answer? What's happening here? Here's my x-intercept. It hits the x-axis at -1. And what is it in factor form? This is a -1. This is a +1. So you need to keep that in mind here in just a few minutes. When you're going from your x-intercept to the factored form, you need to change the sign of the number. Okay, now looking at these graphically. Now, right above these graphs, it gives us a polynomial form. And for polynomial form, make sure you have the highest degree first. So the nth power is the largest, and then n-1, n-2 power, n-3, all the way down to your constant. So make sure your answers are in standard form with the largest power out front. And the instructions say to use the root. What are roots? X-intercept. So use the x-intercept to write the equation in factor form as well as in polynomial form. So we need 2 answers. Our first answer needs to be in factor form. Our second answer needs to be expanded over here into polynomial form. Okay, so the first thing we have to do is locate the x-intercept. So for number 4, this first x-intercept, what is that x-intercept? 1, and what's the x-intercept over here? 5. Now, those are the x-intercepts. when you're going from the x-intercept to factored form, so I'm going to put f of x equals, if I have two x-intercepts, I need to make sure that I have two sets of parentheses. And when you go from your x-intercept to the factored form, you change the sign. So this is a positive 1, so when I write this factor, it needs to be a minus 1. And for the second x-intercept, this is a positive 5, I need to make sure it's a minus 5. So when you go from the x-intercept to the factored form, make sure you change the sign. So that's our first answer. I'll put it number 1, so you recognize this is my factored form, because it has the parentheses. Now, to get the second answer, the polynomial form is this form up here, where we actually have it expanded term by term by term with no parentheses. So what we need to do is we need to take this equation and double distribute so that we can get the polynomial form. So if I double distribute, and I'll put a 2 right here, x times x is x squared. This would give me a negative 5x. This would give me a negative 1x, which gives me negative 6x. And when I multiply the last term, negative 1 times negative 5 would be positive 5. So you have to have both answers. You have to have the factor form as well as the polynomial form. Okay, next one, number 5. Looking at the blue. First, find your x-intercept. What is this x-intercept? Negative 3. What is this x-intercept? Positive 2. And what is this x-intercept? Positive 4. So go ahead and write the factored form. And for that factored form, how many sets of parentheses did you have? 3. You need 3 sets of parentheses. So for the factored form, I need 3 sets of parentheses. And I go left to right, and that's what my answer C will look like. So the minus 3, how do I write that in factored form? X plus 3. And the positive 2, how do I write that in factored form? X minus 2. And the 4, how do I write that in factored form? X minus 4. Now, for part 2, now we have to take the factor form and get it into polynomial form. So to get it into polynomial form, I have to get rid of all those parentheses by multiplying. So the first 2, I'm going to multiply left to right. Now, x times x is x squared, x times negative 2 is, and negative 2x plus 3x gives me, this is positive 3x, this would be negative 2x, and when you add those it gives us plus x, and multiply the last term, 3 times negative 2, minus 6. So I'm going to leave that first answer in parentheses. Now that trinomial needs to be multiplied by x minus 4. So we'll have to double distribute. I'm going to distribute backwards. First, I'm going to distribute this x, so it's x times x squared. X cubed, and x times x, x squared, x times negative 6, negative 6x. And the next thing that needs to be distributed would be that minus 4, or negative 4. So it's negative 4 times x squared. Negative 4x squared. What's negative 4 times x? Negative 4x. And negative 4 times negative 6. Positive 24. And combine your like terms, so this would be f of x equals, polynomial form requires the highest degree out front. So make sure the x cubed goes up front. And combining the x squared, that gives us negative 3x squared Combining the x's, that gives us negative 10x. And then our constant is positive 24. Now number 6. What is this first x-intercept? Negative 5. And what is the next x-intercept? 4. So for our polynomial, not for our polynomial form, we start with the factor form first. Now, notice with this first x-intercept, how many lines are going through it? We have one line going through it. But if you look over here at 4, notice it's coming down, but after it hits this point, what's happening? Going back up. Did it actually go through the point, like over here? No. So this is called a double root. So if it touches that x-intercept and then bounces back up, or bounces back down, if it does not go through it, it is called a double root. And that means when you write your factor form, you need to write it down twice. Or, notice over here, this one, is this a single root or a double root? That's a single because it goes through it. Is this one a single or a double? Single because it goes through. What about this one, single or double? Single because it goes through, single or double? Single because it goes through. Is this one single or double? So it's single if the line goes through that x-intercept. But if it touches the x-intercept and goes back the way it came, it's called a double root. Now let's see what it looks like for factored form. So for factored form, instead of the negative 5, that changes to x plus 5. And for the double root, it's a positive 4, so I changed that to minus 4. And if it's double, you write it down twice. Or instead of writing it twice, another way to write that would be x minus 4 squared. Either way would be fine. If you write it twice or write it as a binomial squared, both answers are the same. And then the second thing we need to do is we need to get this in polynomial form. Now with multiplication, it's commutative. So commutative means it doesn't matter if you go left to right, right to left, you'll get the same answer, right? I'm going to go ahead and square the binomial. That's what I'm going to do first. So if I square this binomial, I would get x squared. And what would I get for the middle term? Negative 8x. I multiply them, get negative 4x. I double it and get negative 8x. And when I square the negative 4, that gives me positive 16. Now we need to double distribute. So I'm going to go ahead and distribute the x first. And x times x squared, x cubed, and x times negative 8x, negative 8x squared, and x times 16, 16x. Now the next thing we need to distribute is the 5. So what's 5 times x squared? 5x squared. And 5 times negative 8x? Negative 40x. And 5 times 16? 80. And combining our like terms, that gives us, make sure the highest degree is up front, so this would be f of x equals x cubed. Negative 8x squared plus 5x squared gives us negative 3x squared. 16x minus 40x gives us minus 24x plus 80. Okay, I want you to go ahead and do that next problem. Does this one have any double roots? No.
Oh.
factored form, what would be the first factor? X plus 2? What would be the next factor? X plus 1. What would be the next factor? X minus 1. And what's that last factor? X minus 4. Now for polynomial form, all of those need to be multiplied. I'll go ahead and multiply these two together and multiply these two together. And then those answers will need to be multiplied together as well. Okay, so let's begin. X times X is squared. These multiply and give us 1x. These multiply and give us 2x, which gives us a total of 3x. And 2 times 1 is 2. I'll group that answer in parentheses to remind myself this needs to be multiplied with this next answer. X times X is X squared. For the outer terms, we get a negative 4x. For the inner terms, we get a negative 1x, which gives us a total of negative 5x. And negative 1 times negative 4, positive 4. Now, instead of double distributing, what do we have to do here? Triple. So let's begin with distributing the x squared. So what's x squared times x squared? X to the 4th, x squared times negative 5x. Negative 5x cubed. X squared times 4. Plus 4x squared. Distribute the 3x. What's 3x times x squared? 3x cubed. And 3x times negative 5x. Negative 15x squared. And 3x times 4 plus 12x. And the last thing we have to distribute is the 2. What's 2 times x squared? 2x squared. And 2 times negative 5x, negative 10x. And 2 times 4, 8. And again, for polynomial form, make sure the highest degree is out front. So this would be x to the 4th minus 2x cubed. And 4 minus 15 is negative 11. Negative 11 plus 2 would be negative 9 for the x squared term. And positive 12x, negative 10x gives us positive 2x. And the constant is 8 at the very back. That was fun. Okay, on the back, here's some definitions for us. The first one is called the rational root theorem, and it's also called the rational zero test. And it says that if you have a polynomial in standard form, then all the possible rational zeros, and what does zeros mean? X-intercept. So all the possible x-intercepts are this ratio P of x over Q of x. Now that makes no sense until you read that next line. And the next line says that P of x is all of the factors of the constant, which will be this number back here when it's in standard form. So here is P of x, if you want to label it. So P of x are all the factors of the constant. And Q of x is all of the factors of the leading coefficient. So the leading coefficient will be this one right here, which would be Q of x. So you need to factor your constant and find all of the possible factors for the leading coefficient. So number 8, find all the possible rational zeros for that polynomial. Y equals x cubed plus 8x squared plus 4x minus 48. Okay, so let's begin. First thing we have to find all the possible rational zeros, we have to find P of x over Q of x. And they defined these for us. They said P of x is all of the possible factors for what? The constant. So my constant is what? Negative 48. Just ignore those negatives. We're finding all the factors for 48. Now, we could have plus or minus. We could have a positive 1 and a negative 48, or a positive 48 and a negative 1. So we'll put a plus or minus out front to remind us that either one could be positive, the other one could be negative. Now, listing all the possible factors of 48. Well, I could have 1 times what? 48. I could have 2 times what? 24. I could have 3 times what? 16. I could have 4 times what? 12. 5 is not a factor. I could have 6 times 8. 7. Is 7 a factor? Is 8 a factor?
Yes.
Is it already in my list? Good. So did you see how I wrote those factors? I wrote the smaller one out here, 1 and 48, 2 and 24. That way it would be in order. Now that's just for P of X. Now we have to have Q of X in the denominator. Same thing. This could also be plus or minus. And they said Q of X is all the possible factors for what? The leading coefficient. And so this problem, what is the leading coefficient?
1.
It's a 1. Well, what are the only factors of 1? 1. Okay, so if I listed all of the possible factors, I need to divide every single one of these combinations out. So it's going to be a lengthy list. I could have positive or negative, and if I divide these, I get 1. I could get positive or negative 2, positive or negative 3, positive or negative 4, 6, 8, 12, 16, 24, 48. So you actually do have to divide them. Sometimes, well, most of the time, you're not always going to have a 1 in the bottom. It might be a 2. So my factors would be plus or minus 1/2, plus or minus 1, plus or minus 3/2, plus or minus 2, etc., etc. So it's not always a 1 in the denominator. So there's all of the possible rational zeros. Now, am I going to have that many x-intercepts? No, these are just the possibilities it could be. I might just have 2 x-intercepts. I might only have 1. Or I might not have any at all. Okay, now the next text box, more definitions. That next definition is called the remainder theorem. And it says that if a polynomial is divisible by this factor, x minus k, then the remainder, what does remainder mean? What's left over. So what's left over, we're using r to represent the remainder, is going to be f of k. So what that means is if this is the factor, notice right here we have a negative k, you change that to a positive k, substitute it into the equation, and whatever answer you get is going to be that remainder. Now, we don't use that too often. We really use this next one, but you have to know this information for this one to be true, which is called the factor theorem. And the factor theorem is what we're going to use. And it says that a polynomial has a factor x minus k if and only if f of k is equal to 0. Which means up here it was f of k equals what? R. So this means that if your remainder is equal to 0, that means that value for k is actually an x-intercept. So if you substitute that number in, and the answer is 0 to that function, and you substitute in, then that is a true x-intercept for that polynomial. So for this next step, it says determine if a given value is a root using synthetic division, and your answer just needs to be yes or no. So yes is a root or no it's not. So we're given the polynomial f of x equals x cubed plus x squared minus 14x minus 24. They wanted to test is negative 3 a root. So negative 3 is the number that we're going to test. Remember with synthetic division, you have this number over here to the side, and we put a half box around it. And again, they did tell us to use synthetic division. So if the instructions say use synthetic division, make sure you're using synthetic division. Now with synthetic division, the next step is you need to write all of your coefficients across the top row. For x cubed, the coefficient is
1.
1. For x squared, it's
1.
1. For x, it's
Negative 14.
negative 14. For the constant,
Negative 24.
negative 24. Skip a row, draw a line. Now, with synthetic division, we're going to multiply the outside numbers. So your first step is drop down the leading coefficient. And I do need to interject and let you know, what if I had a term missing? You make sure you put that 0 in. So just as a reminder, if you have a term missing, then in your list of coefficients, you would put a 0. Okay, so the leading coefficient is dropped down. Now, outside numbers get multiplied. So it's negative 3 times 1. That answer goes right here in the next hole. Now, we combine these together with addition. So what's 1 plus negative 3? Combining those, we get negative 2. Outside numbers get multiplied. So it's negative 3 times negative 2. Positive 6. That answer goes in the next spot. Now combine these with negative 14 plus 6. Negative 8. Outside numbers get multiplied, so it's negative 3 times negative 8. Positive 24. And when you combine the last column, you get 0. And this last number is called your remainder. And from this factor theorem, if that remainder is equal to 0, that means yes, it's a root. So your answer is yes. So if the remainder is 0, the answer is yes. Next one, number 10. They ask, is negative 2 a root? So negative 2 is the x-intercept we're checking. The list of coefficients are the same. We have 1, negative 14, negative 24. Skip a row. And I want you to go ahead and test negative 2. So figure out, is negative 2 an x-intercept for that polynomial? Okay, that leading coefficient needs to be dropped down. Multiply the outside number. So it's negative 2 times 1. Negative 2 goes in that next spot. Combine this column, we get negative 1. Outside numbers get multiplied, and this gives us positive 2. Combine this column, it gives us negative 12. Multiply the outside numbers, that gives us positive 24. And when I add these, I get 0. So my remainder is 0. So is that going to be a root? Yes. Now if the remainder was 1, would it be a root? No. Okay, next part, determining the end behavior. So when you are graphing, is this what's over here? Or do you have this? Okay, you have it. Okay, good. Okay, so talking about the end behavior, that means when you're graphing a function, what do the arms look like? Are they pointing down? Are they pointing up at the very end? Okay, so we are given our standard polynomial. There's our polynomial form. Now, here, they're telling us that n is even. So n, notice n is the highest power. So you need to look to see what is the highest power. So it needs to be in standard form. Now, if your highest power is even, that means if you have like y equals x squared, that means if you had an even exponent, it doesn't have to be squared, it could be y equals x to the 4th, x to the 6th, x to the 8th, etc. That's the first thing you need to check. What is the power? Is it even or is it odd for the highest power? Then the next thing you need to check is the leading coefficient. So this a sub n is just the leading coefficient. And for this one, the leading coefficient is greater than 0, which means it's positive. So if the leading coefficient is positive, that means both of them point up. And that's true if it's even. Like if I have y equals x squared. Think about that quadratic parent function. Both arms point which way? Up. But over here, if it's even and and the leading coefficient is less than 0. So if your leading coefficient is negative, so an example would be y equals negative x squared. Well, what does that negative leading coefficient make it do?
Open down.
Open downward. So what you need to notice is for the even function, both arms point the same direction. So they both point up or they both point down. So the even functions both point in the same direction. So if you had x to the second, x to the fourth, x to the sixth for the highest power, they're both going to point in the same direction. So they both point up or they both point down. You need to be actively taking notes. Now, what if it's odd? Like x to the third, x to the fifth, x to the seventh. An example would be y equals x cubed. So here, my highest degree is odd, and my leading coefficient is positive. So if you think about the cubic parent function, that left arm points down and the right arm points up. Over here, if n is odd, so I'm going to keep it as x cubed. But now my leading coefficient is negative. Well, what happens to that cubic parent function when I put the negative out front? It reflects. So that left arm no longer points down. It is now pointing up. And the right arm points down. So what you need to notice is that for the odd function, they point in opposite directions. So one arm points down, the other one points up. So if it's even, they point the same direction. They're either both up or they're both down, depending on that leading coefficient. So those are the two things you need to check. Look for the highest power and determine is that leading coefficient positive or is it negative. Now we're going to be using those rules to create some graphs. Okay, the next problem is says to find the roots of each polynomial by using synthetic division, write it in factored form, draw a graph, no calculator needed. So this is all about a calculator. So starting off with y equals 3x squared plus 5x minus 2. Now here is a trick. Look for your highest degree. My highest degree is 2. That means I should have 2 x-intercepts. So I should have 2 factors when I write it in factored form. So the first thing I need to do is if I'm finding the root, I need to use that rational root theorem, which was that P of x over Q of x. And what was P of x?
The factors of the constant.
Factors of the constant, which are negative 2. Well, what are the only factors for 2?
1 and 2.
1 and 2. Now for Q of x, what was Q of x? It's all the possible factors for what? The leading coefficient, which is 3. Well, what are the only factors for 3? 1 and 3. So all of my possible factors, I could have, if I divide these, it would be positive or negative 1, positive or negative 2. If I divide these, it's positive or plus or minus 2, plus or minus 2/3. So those are all of the possible x-intercepts. But because of this degree of 2, only 2 of these will actually work. So to test these, we are going to tell us to use synthetic division? Yes. Okay. So we need to find roots. Now before I start doing a bunch of unnecessary work, I know that whenever I substitute this x-intercept in order for it to be the true x-intercept, the y value has to be 0. So I just start with what's easiest. So let's start with 1. So if I plug in a 1 right here and a 1 right here, does that give me 0? No, that gives me 3 plus 5 minus 2, which is not 0. So positive 1 didn't work. So positive 1 didn't work. Let me try negative 1. So 3 times negative 1 squared plus 5 times negative 1 minus 2. Negative 1 squared is positive 1, so 3 times 1 is 3. 5 times negative 1 is negative 5, then we'll have minus 2. Does that add up to 0?
No.
No. So positive and negative 1 don't work. What do you want me to try next? Let's try 2. So if I substitute in a 2, let's start with positive 2. This would be 3 times 2 squared plus 5 times 2 minus 2. Is that going to give me 0?
No.
No. So what if I change it to a negative 2?
Yes.
Yeah, negative 2 squared is 4. 3 times 4 is 12. Oops, that's not a plus. This would be a minus 10. Minus 2 gives me 0. So bingo, that's where I need to start. I need to use negative 2 for my synthetic division. So substitute in all of those possible rational zeros until you find one that when you substitute it in, it gives you 0. So negative 2, that's the magic number to put it in the box. Now for synthetic division, we need to write all of the coefficients across the top row. So for x squared, put the 3. For x, put the 5. And the constant is negative 2. Drop down the leading coefficient and multiply with 3 times negative 2. Negative 6 and 5 minus 6. Negative 1. Multiply these. Negative 2 times negative 1 gives me positive 2, and when I add these, it gives me 0. So if my remainder is 0, that means negative 2 was one of the solutions. Now, when I do the synthetic division, this will give me the other factors form. So let me go ahead and write my equation in factors form. The first factor we had, actually I haven't been using y, I've been using f of x. Oh, but they use y, so I'm going to use y. So just follow suit. If they're using y, your factor form needs to have y as well. So for the first factor, if my first x-intercept is negative 2, what would that be in factor form? X plus 2. And my other factor will be right here, but these are just the coefficients. And remember that when you're writing this answer, you need to drop it a degree. So if we started with x to the second, that would be x to the first, and here's my constant. So my second factor would be 3x minus 1. So now I have my equation in factor form. So now I'm ready to sketch a graph. So out to the side, sketching a little x-axis. And my x-intercept, what would this x-intercept be?
Negative 2.
My x-intercepts are negative 2, and this one would be what? 1/3. So, go ahead and mark it. Here would be negative 1, here would be negative 2, and at negative 2, we have an x-intercept. Over here, I really just have to go out to 1, and we're going to have an x-intercept at positive 1/3. Now, really, the next thing that would be nice to have would be to have the y-intercept. And if you want the y-intercept, what do you put for x?
0.
So what happens when I put a 0 here and a 0 here? Negative 2 would be the y-intercept. So let's go ahead and put negative 2 for the y-intercept. If I said x-intercept, I put y-intercept. Okay, from these points, now I'm ready to sketch a graph. Now to sketch a graph, I have to recall all of these rules from that previous table. Now first I have to look at the highest power. The highest power is x squared. So if it's even, that means they both either point up or they both point down at the very end. So this is talking about the arms. Do the arms point up or down? Well, the next thing I have to do is look at the leading coefficient. So is this a positive 3 or a negative 3? Positive. So if it's positive, they both point which way? Up. So that means when I'm drawing it, the left arm should point up, the right arm should point up as well. So they both point up. Now, I need to do some squiggly work in between. So come down, go through your x-intercept, go through the y-intercept, the x-axis, and finish out that arm. So since it's even, they both point in the same direction, and since the leading coefficient is positive, they both point upwards. Next one, now we're stepping it up a degree. So looking at the highest power, how many factors should I have? I should have 3 factors in my answer. So the first thing I need to start with is what are the possible values for those x intersect. So we need to see the p of x over q of x. And p of x are all the possible factors for the what? Constant. So my constant is 6. So factors of 6, I could have plus or minus 1, and 1 times 6, or I could have 2 times 3. Now for q of x, q of x are all the possible factors for what? The leading coefficient, and our leading coefficient is 2. So the only factors of 2 are 1 and 2. Now I have multiple x-intercepts in this x. I could have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. I could have plus or minus 1 half, plus or minus 1, plus or minus 3 half, plus or minus 3. Now I can start with what's easy. Where do you want to start with? 1. So if I put in a 1 right here, this would be 2 times 1 cubed plus 1 squared minus 13 times 1 plus 6. Does that give me 0? No. What about if I put in negative 1? Will that give me 0? So plus or minus 1 doesn't work. So what can I try next? Plus or minus 2? Let's see, 2 cubed is 8, so 2 times 8 would give us 16. 2 squared would give us 4. Negative 13 times 2, negative 26, plus 6. What does that add up to? Oh, okay, good. So what number did we use? So 2 goes on the corner for our synthetic division. Okay, so now the leading coefficients, all of the coefficients need to go across the top row. So what do I put across that top row?
2, 1, negative
2, 1, negative 13, and 6. Drop down to 2. 2 times 2 is 4. 1 plus 4. 2 times 5. Negative 13 plus 10. Negative 3. 2 times negative 3. Negative 6. And 6 minus 6 is 0. Now the next thing I would do is to get it in factor form. They didn't use f of x, what did they use? Y. I love it. The 2, since the remainder is 0, 2 is going to be the x-intercept. So if that's the x-intercept, how do I write in factor form? X minus 2. Now this will be the other factor, and if I drop it a degree, what degree did we start with? X cubed, so this would be x squared plus 5x minus 3. So this would be 2x squared plus 5x minus 3. Now since we had a cubic, how many factors do we have to have in factor form? 3. How many factors do we have? 2. We have 2 groups of parentheses, right? So I need to see if this factors. And it should. So I have to have a 2x and an x. And what would we have to have here? If I put a positive 3 here, this would give me positive 6. And what would I have to have right here? Negative 1. Now how many factors do I have? Now I have all 3. Now I'm ready to start graphing. So what is x minus 2? What is that x-intercept? 2, positive 2. And for 2x minus 1, what would that x-intercept be? 1 half. And for x plus 3, that x-intercept would be? Negative 3. Now to sketch the graph, I'll do it over here. Negative 3. you are numbering these so I can tell what you're counting by. And for the y-intercept, if you want the y-intercept, that means x is what? 0. So our y-intercept, if I put zeros over here, that y-intercept would be 6. So my y-axis needs to go up to 6. Okay, so plot the y-intercept. The y-intercept is at 6. Then plot your x-intercept. So we have an x-intercept at positive 2, at positive 1/2, and negative 3. And now I have to decide, what are the arms going to do? Do they both point up, or do they both point down? So looking at the highest power, is it even or odd? Odd. If it's odd, that means one of them points down, the other one points up. And the leading coefficient is positive, so which way does the left arm point? Down, just like the cubic. So the left arm needs to point down, and the right arm does the opposite and points up. So the left arm points down, and that right arm is going to point up. Now, from this left arm, go through the x-intercept. The next point would come across would be the y-intercept. And it's going to come back down through this x-intercept. I don't know how far it comes down, but I know it has to come back around at some point. And tomorrow we'll find maximum and minimum on the calculator. So here, that's just a good enough sketch for us. Our main focus is, did you find the x-intercept using synthetic division? Did you find the y-intercept? Do you know what the end behavior is for those arms? Okay, this next one and last one, number 13. Looking at the highest power, how many answers did you have in your factor form? 3. I want you to go ahead and start 13. So go ahead and do problem 13. Okay, let me know if you do not hear your name. Chris, Kayla, Kate, David, Caleb, Nate, William 3, the other William, Hannah, Noah, Keenan, Minhal, Abby, Yusuf, Magdiel, Brett, Joel, Austin, Takanori, Elizabeth, Morgan, Riley, and Haley. Anybody not hear their name? Did you check out a textbook in the library? Anyone else not hear their name? Okay, listing out all the possible rational zeros. P of x over Q of x. For factors of 20, I could have 1 times 20. I could have 2 times 10. 4 times 5. And for Q of x, for the leading coefficient of 3, factors of 3 are 1 and 3. So lots of possible factors. What is one of the x-intercepts that you found? -2? Let's try -2. And if I put the leading coefficients, this would be 3, 17, 32, and 20. Drop down to 3. What is -2 times 3? -6 was 17 minus 6. 11 was -2 times 11. -22 was 32 minus 22. 10 was -2 times 10. -20, and 20 minus 20 is 0. So -2 is going to be one of the factors. So if I write that in factor form, this would be f of x equals, for -2, how do I write that in factor form? X plus 2. And this one would be 3x squared plus 11x plus 10. So how many factors do I need? 3. So I need to factor this trinomial. So we'll have to have a 3x and an x. do a positive 2 here, and that gives me 6x. So what would have to go right here? 5. Now, you don't have to have it in this form, but if you notice, what if here's twice? X plus 2, so x plus 2 is going to be a double root. Now, if you wrote it as x plus 2 squared, that's fine too. Now, do they have to be in this exact order? No. As long as you have those three, even if you put the parentheses squared for x plus 2, that's fine too. Now, writing these as x-intercepts. What's the x-intercept for x plus 2? Negative 2. And what is the x-intercept for 3x plus 5? Negative 5/3. And what is our y-intercept? If I put in zeros,
20.
it would be 20. I count by 5, so here's 5, 10, 15, 20, and the y-intercept is right there at 20. Our x-intercepts are at negative 2 and negative 5/3. So negative 2 is one of the x-intercepts, and negative 5/3, 3 goes into 5 one time, there's 2 left over, so that would be negative 1 2/3, which would be, let me change that to Okay. Now we have to determine what is it going to look like. What is it going to look like as far as the end behavior? So are both arms pointing up, or is one pointing up and the other pointing down? So look, the highest power is x. Oops, that's not the highest one. Highest power is what? Even or odd? So if it's odd, do they both point up, or do they do opposite? Opposite. So one arm is going to point up, the other one is going to point down. Now, looking at that leading coefficient, will the left arm point up, or will the left arm point down? Left arm needs to point down. So the left arm points down, and the right arm needs to point up. Now, to continue my function, I'm starting with this left arm. I need to go up to negative 2. But what do you remember about negative 2? It was a double root, so do I go through negative 2? No, I do not go through negative 2. It hits negative 2 and comes back down. But eventually I'll have to turn back up to go through that second x-intercept, and then the y-intercept, and that right arm needs to point up. So if it's a double root, make sure you do not go through the x-axis. You hit the x-axis and go back to the direction you came from. Okay, your assignment is on your own notebook paper.